Okay, so let's do another example. I'm going to just use max profit 12x1 plus 8x2 subject to, and we're going to have x1 plus 2x2 less than equal to 40, 3x1 plus x2 less than equal to 45, and then we're going to have x1 and x2 is greater than equal to 0. So if you don't have to draw your feasible regions and everything, you can basically investigate it in this situation. So in this situation, we only have 2 lines, and then we have the non-negativity constraints. But let's go ahead and actually draw this on our Desmos so we can just get an idea of what's going on. I'm hoping that my Desmos works on my tablet correctly. I couldn't type earlier, so let's just see if I can type. 12x. I'm just going to close this slide over. I'm going to close this quick so I can type it. 12x plus 8y and I'm going to refer to this as P equals. My other equation is x plus 2y, and it was less than equal to 40. So we want to just write this as greater than equal to 40. So it colors in the region that we don't want. There we go. You can see colors in the region we don't want. And then we're going to have the 3x plus y. And the equation again was less than equal to 45. So I'm going to be greater than equal to 45 to color in the region I don't want. And then my non-negativity constraints. So remember, we want x to be greater than equal to 0. So again, to color in the regions I don't want, we just change the signs around. And let's do the y one as well. There we go. So there we have our feasible region. And let me just fix this quick, because I want the slider to show. There we go. And change the color of that to orange. So now we have technically done drawing our feasible region and seeing what our objective function is. I need to change the step size here to be something bigger. So now you can see we can move it around, and if we want to maximize it, it's going to be at that point over there, which happens to be the 10 and 15 point. Okay, so I was very lazy. I drew it on Desmos so you can see it. And we can see that our maximum point is at 10 and 15, which means the purple constraint and the blue constraint are the constraint that is keeping our objective function tangent at that feasible region. Okay, so it's the constraints that make up your corner point. So when we did the simultaneous equations, it's those constraints that make up that corner point. So we're going to be investigating the blue constraint and the purple constraint to determine our range of optimality. So let's go back to our freeform and go from there. So we now know, because we've done the work, that it was our purple constraint and our blue constraint. I wonder if I can do this as purple. There we go. And our purple constraint was the top one. It was this one. And our blue constraint, so it was this one. So both of those make up our corner point where P is 10 and 15. Again, if you just need a reminder of it, it's the 10 and 15 points that sits over there. So it's those two equations are giving us that corner point for an optimal. So we're going to have to investigate the gradients of those two equations with the gradients of our objective function. So let's go and do that. So let's go and do the first one. So equation 1, which is x1 plus 2x2 less than equal to 40. Now, I'm going to leave it as x1 and x2 just so that you can recognize that we can use other values for our variables, but to just follow the same process. So I'm going to make x2 the subject of the formula. And if I make x2 the subject of the formula here, I'm going to do it in all of them the same way. In your quizzes online, they're pretty clear about which one you need to do. You usually follow an order of like the first one will be X and the second one will be Y. That's the default process. But as long as you maintain consistency, you will get the correct answers. So x2 is the subject of the formula. So we're going to have 2x2 is less than equal to minus x1 plus 40. So x2 is going to be less than equal to minus 1 upon 2x1 plus 40 over 2, which is 20. We don't really care about the coefficients. We only care about the gradients. So we care about that over there. Now we're going to do it for the second line. So our second line was, let's just remind you about it, 3x1 plus x2 is less than equal to 45. Again, we're going to make the x2 the subject of the formula. So we're going to maintain our consistency. So that's going to be x2 less than equal to minus 3x1 plus 45. And that's the gradient that we're interested in. So we have a gradient for equation 1 and we have a gradient for equation 2. We still need the gradient of the objective function. So objective function, and again, just to remind ourselves of it, it's p is equal to 12x1 plus 8x2. So a reminder of the original one, p is equal to 12x1 plus 8x2. But remember, what we're going to do is we're going to be like, okay, this is A and that is B when we do our working out. And once again, we will make x2 the subject of the formula. And if that's the case, we are going to get bx2 is equal to minus ax1 plus p, with x2 is less than equal to minus a upon b, x1 plus p upon b. And again, we only care about the gradient. So that is the gradient of the objective function. So you're going to notice there's a pattern here, particularly if you make the second one y, it will always be minus a upon b for objective function. And now we need to take the objective function's gradient and show the range it can be in. So remember, it has to be between M1's gradient and M2's gradient. So we need to figure out which one's bigger and which one's smaller. So let's just quickly do the number line again, because we have a minus 3 and a minus 2. Minus 3 comes there and minus 2 there, and then you have 0, etc. So this is the smallest one, and that's the biggest one. So we know our m of our objective function needs to chill somewhere in between these 2 points. So we're going to write that. So let's try and fit this all on one piece of paper. There we go. We're going to then say, okay, our minus a b must be less than equal to minus a half and greater than equal to minus 3. So once again, we need our objective function to be between those 2 points. That's why we have it as less than equal to minus a half and greater than equal to minus 3. And now we can investigate each individual's A and B range. So if we want to work out the range for A, I'm going to try and fit it in here so you can see the whole screen. The range for A, we set B as the original value. So in our case here, B is 8. So we're going to have minus 3 less than equal to minus A, 8 less than equal to minus a half. And then we're going to multiply through by the 8. So we're going to have minus 3 times 8 less than equal to minus A, less than equal to minus a half times 8, which is 4, but let's just go with this at the moment. Then we're going to multiply through by the negative. And remember, whenever we multiply through by the negative, we change the signs. So we're going to have 3 and 8 must be greater than equal to A, which is greater than equal to 8 upon 2. And now we can just go ahead and simplify it. So in this case, I have to remember my multiplications. 8 times 3 is 24. And that is 4. So now we have the range of A. An alternative way to write this is if we do this, 4 and 24. So again, just be very careful, particularly when you're filling it in online, because we indicate the signs. So just take note of what the signs look like when you fill in your values. That one is equivalent to that one. So just keep that in mind. And now we have to work out the range of B. So to work out the range of B, we set A as the original, which means it is 12. So let's just do that so we can fit it in. We're going to have that minus 3. We're going to have 12B less than equal to minus a half. And again, I'm just going to follow the long way because I'm more comfortable with the long way. You don't have to think as much. So let's go through it like that, where we separate them into two equations. So minus 3 minus 12 over B and minus 12 over B less than equal to minus a half. We multiply through by B, minus 3B less than equal to minus 12. Minus 12 less than equal to minus B upon 2. And this thing is in the way. Oh, there we go. I was done with B. So now we can make B the subject of the formula. So we're going to have B, and it's dividing through by minus 3, so the sign is going to change. So that's going to be greater than equal to 12 over 3. And the reason why the sign is removed there is it's minus 12 over minus 3, which gives you 12 upon 3, which is 4. We're going to do the other side. To get rid of the 2, we're going to multiply it through by 2. So we have minus 24 less than equal to minus B. Then we're going to multiply through by the minus 1. So we're going to have 24 greater than equal to B. Now we need to just write it in proper range order. So let's just do that so you can see. If we have B must be greater than equal to 4 and we have B must be less than equal to 24, that's telling us that our range of B is greater than equal to 4, less than equal to 24. That's one way we can write it. We can also write it as 4 must be less than equal to B, and B must be less than equal to 24. And again, just make sure when you're filling it in what the signs are on the online documents, because both of those are equivalent.